trig review. Well, this is just to let you know ahead of time, it's not going to include radians and loss sine and cosine. That we are going to do next. So this is just some of the more basic things. Like if I gave you a triangle, and let's say I gave you all three sides and said find the 6 trig ratios for A. Remember, you've got sine, cosine, tangent. And to remember what goes where, remember you have SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And remember, no matter if your angle is here or there, it always goes by the same principles. Opposite from this angle, you literally start at the vertex of the angle and walk straight. And that's opposite. Your hypotenuse is always opposite from the right angle. And adjacent means next to, so that one's adjacent. So sine of A, opposite over hypotenuse, 15 over 17. Cosine, adjacent over hypotenuse, 8 over 17. And tangent, opposite over adjacent, 15 over 8. Now I know you're like, wait, you said there's 6 of them. Remember, the reciprocal of sine is cosecant, cosine is secant, tangent is cotangent. And remember, the easy way to remember it, one S goes with one C. So there's never 2 S's together. There's never 2 C's together. Sine goes with cosecant. Cosine goes with secant. And since they are reciprocals, we literally flip them. And that's it. Now, on the ACT, they're more than likely not going to give you something like that. They're going to give you something like this. Sine of X is 3 over 5. Find tangent of X, or find secant of X, where all you have to do, they're going to give it to you so you can draw it. So sine is opposite over hypotenuse. So opposite hypotenuse. And see, if you just had this side, you could find any of the 6. Guess what? Pythagorean theorem. So 3 squared plus x squared. Remember, hypotenuse always by itself. And yes, I did, for those that already know, I did a Pythagorean triple. Subtract the 9 to get 16 because I wanted it pretty for you. So x is 4. And once you find it, you can find anything they want. Tangent of x, opposite over adjacent, 3 over 4. Secant, remember, goes with actually cosine. So cosine of x, adjacent over hypotenuse. But to make it secant, flip 5 over 4. So this is how they like to, at least one question on the ACT, they like to give it to you like this. So you have to draw the triangle. Typically, you have to do Pythagorean theorem to find the missing side. And then you have to know which ones go together. So it just like, as you can see, it does a little bit of difficulty to it. But now let's find some pieces. Well, let's say 10. Or what's another one we can do next? Maybe x and 7 and 56. So if I wanted to find x on these, you can use your calculators and you can find them. But first, before you get to your calculator, you have to know which ratio you're going to use, sine, cosine, or tangent. Always go with response to the angle they either give you or want. Well, you know 10's a hypotenuse. This side's opposite, so adjacent. So adjacent and hypotenuse has to be cosine. So cosine of the angle equals adjacent over hypotenuse. And remember, if x is on top, you multiply, because actually you're just cross multiplying. Now remember, there's two different calculators. There's ones like these. If you're doing with one similar to this, first make sure you're on degrees. And since you're doing 10 times the cosine of 37, on these particular ones, you have to do the angle first, as far as once you get to the cosine. So you would do 10 times 37 cosine equals. And of course, you get 7.98, or right at 8. Same thing with this one, but make sure with degrees. But most of you probably have these, or forms of them. And this is actually the one that my personal students use. So I'll be using it most of the time. But as far as the process, this one is the next best thing. Because see, on these, you can just do 10 times cosine 37 equals. And you can see it's glare on mine, 7.98. So these are a little bit more user-friendly. And of course, the same on those. 10 cosine 37, 7.98. Now let's say this one. Well, we know hypotenuse is easy to identify. And we've got opposite. So, what includes opposite and hypotenuse? Sine. So sine of 56, opposite over hypotenuse, so 7 over x. Notice how this time the x is underneath. Well, if x is underneath, you're going to divide. 7 divided by sine of 56. So 7 divided by sine 56 equals 8.4. All right, but I know you're like, wait, what if they give me the angle? Okay. Let's say, or if they want the angle, let's put it there, and maybe a 9 and a 12. Let's say they want the angle. Well, you see, which one does it involve? Well, there's the hypotenuse. They don't give us the hypotenuse, so that means the only one that doesn't include the hypotenuse, tangent, because you've got opposite and adjacent. So tangent of what equals 12 over 9? And remember, to find the angle, you always hit second. So we're going to hit second tangent, 12 divided by 9 equals. So it's going to look something like this. Second tangent, 12 divided by 9 equals 53. So you can find, if they give you two sides or if they give you an angle and a side, you can automatically find the other by using trig. Now let's say you're doing 30, 60, 90s, or 45s, special right triangles. The side opposite 30 is always x. The side opposite 60 is x times the square root of 3 is its ratio. And the hypotenuse is always double. And on a 45, the legs are equal because it's two 45 angles. And then the hypotenuse is x squared of 2. So given this, if they give you a right triangle, which they are fairly common on the ACT, and we personally do them all the way to pre-cal and beyond, if they give you, let's say the hypotenuse is 8, the side opposite 30 is 4, side opposite 60, 4 square root of 3. let's say they give you the side opposite 60 is 5 square root of 3. Well, that means the side opposite 30 is 5, and the hypotenuse, 5 times 2, 10. Let me get another sheet of paper. All right, let's say this is 30. And the hypotenuse is 18. The side opposite 30 is 9, 60, 9 square root of 3. The weird case, which doesn't come into play too often, but let's say they give you the side opposite 60 without the square root of 3. Remember, if you want to find the side, like in this case, you would just divide by whatever the side opposite 30 is. So 9 square root of 3 over 9, or rather divide by square root of 3, so you just get 9. Well, 12 divided by, let me show you the long way, then I'll show you the shortcut. 12 divided by square root of 3, if you rationalize 12 square root of 3 over 3, which is 4 square root of 3. So remember, the shortcut is divide by 3, attach the square root of 3 with it, and then that means the hypotenuse is double it, so 8 square root of 3. Just like, let me do one more just to, because those are typically the weird ones. If this was 15, the side opposite 30, divide by 3, put the square root of 3 with it, hypotenuse double. During the virus, since we're out, I don't even know that I would give you one of those. If it was normal school, oh yeah, you better believe it. But anyway, now 45s are a little bit easier to deal with because remember, it is just x squared root of 2, where 2 of the legs equal. So if I were to give you this side is 8, you know, 8 square root of 2. Or if I gave you the hypotenuse was 10 square root of 2, 10 and 10. Now the weird one on it, because I know you're like, okay, what's the weird case on it? Let's say if I gave you the hypotenuse was 10 without a square root. You're going to do the exact same thing, except since 45s have square root of 2s, you're going to divide by square root of 2. And I'll go through the process for those math-minded people. 5 square root of 2. But for those of you who are like, if there's a shortcut, if there's a pattern, give it to me. Well, the pattern is divide by 2, square root of 2 goes with it. Divide by 2 to get 9, square root of 2 goes with it. And that one's also popular on the ACT. They do love their 45s. Now, the trig word problems, remember they're not that bad. You just have to know what goes where. You've got ladder, eyesight or flight distance is always the hypotenuse. Shadows, ground distance, distance from the base is always down here because the base is there. And then you've got trees, building heights, altitudes, things like that over there. And remember, this angle right here is the angle of elevation. Now, technically, I'll draw an airplane real quick. If you had an airplane with an angle of depression, remember, technically it's outside the triangle, but since the flight is parallel, then by alternate interiors it equals. So that's why I tell you the angle of elevation or depression, if you're drawing it like this, you can put it there. So if I said a fella had an angle of elevation of 35 degrees and he was standing 10 feet from the base of the tree, what is the tree's height? Well, you literally just draw the pic. If you want to be cute, you could. But find the height of the tree, angle of elevation, and 10 feet from the base of the tree. And then sine, cosine, or tangent, just like the ones we were doing a minute ago. You've got opposite, not the hypotenuse, and the adjacent, so tangent. Tangent of 35, opposite over adjacent, x over 10. And remember, since x is on top, you multiply. So 10 tangent 35 equals 7. Technically, you were in feet. 7 feet. Now, last but not least, trig in the coordinate plane or quadrantal angle. Here's where the special angles, the triangle, come into play. If you have sine of 30 or cosine of 120 or tangent 315, you can find it without using a calculator by using special right triangles. Now, where they come from, this tells you what quadrant. Remember, if it's like sine of 30, that first quadrant. So it's as is. I'll just put as is. The second quadrant, because remember, you always draw it from the x-axis. So you're going to subtract from 180. Technically, third quadrant, you subtract 180 from it. But if you want, you can just say 180 minus and just know it's not actually negative. Fourth quadrant, subtract from 360. So, and where the sides come from, this you just have to know. What we were just doing, the 30/60s, instead of x, let's make it 1 for a unit circle. Well, technically this is 1, so never mind. So just let's make it 1. 60 squared to 3, radius or hypotenuse 2. For a 45, sides are 1, hypotenuse 1 squared to 2. And I know it's a lot of stuff, but it gets better. So, sine of 30. Always draw back to the x-axis. Put your sides in. 1 squared to 3, 2. And you could actually, from this point, find any of the 6. Sine, tangent, cosecant, any of them of 30. Because sine of 30, opposite over hypotenuse, 1/2. And first quadrant, as is, everything is positive, so you're done. Let's say 120. Cosine of 120. Well, that's between 90 and 180, so second quadrant. Subtract from 180 to get 60, because you always want that angle right there. Well, opposite 60 is square root of 3, 1, 2. Cosine is adjacent over hypotenuse, 1/2. But you notice how you're in the second quadrant, so the signs are going to change. Sine is positive in the second, tangent's positive in the third, cosine is positive in the fourth. In other words, if it's not positive, you know it automatically has to be negative. So in the second quadrant, if sine is positive, that means cosine negative. Now, let's do it again. 315 has to be between 270 and 360. So fourth quadrant. Subtract from 360 to find this angle. 45. 1 square root of 2. And tangent, opposite over adjacent, or 1. And fourth quadrant, cosine's positive, so tangent, negative. Now let's say you even wanted one of the reciprocals. Maybe let's say secant of 240. Well, we know secant goes with cosine. And 240 is in the third quadrant, so subtract from 180. 60. You put in your sides. Square root of 3, opposite 60, 1, hypotenuse 2. So cosine would be adjacent over hypotenuse, or a half. Secant, you flip it. And then last but not least, tangent is positive in the third. So cosine and secant, negative. Now, last but not least, let's say if they literally give you 90, 180, 270, or 360, you can actually find the sine and the cosine by literally, if you went 1 to the right, your coordinate would be 1, 0. If you went up 1, your coordinate 0, 1. Left 1, negative 1, 0. 270, 0, negative 1. And you might be like, okay, how does that help me? Well, remember, cosine always goes with x, sine y. So if I wanted you to find cosine of 90, 0. If I wanted you to find sine of 90, 1. Sine of 270, negative 1. Because literally, you can find any of them. If I said find sine of 360, 0. Now let's say I wanted cosecant of 360. Well, cosecant of 360, well, if sine is 0, and over and understood 1, if I flip it, undefined. And last but not least, the only one I haven't shown you, because I know you're like, what about tangent? Tangent, by definition, is sine over cosine. So if I wanted tangent of 180, sine over cosine, 0 over negative 1, 0. Or let's say I wanted cotangent of 270. Well, I know that goes with tangent, so tangent of 270, sine over cosine. But since it's cotangent, I'm going to flip it, so 0. Sadly, like I said, this one's not going to include radians or graphs or law of sine or cosine, but that will be in a second video. It's not on the test for this year for those that are involved with the virus, but for future years it would be. So I'm going to attach or do another video later. Have a great day.